And we're back for the last session of the day. Thank you very much for everyone who made it till this last session. Thank you, Piotr, for being with us. Hi, Piotr.
Hello.
Hello, how are you?
Fine, and you?
Excellent. Look what I've got for you.
Okay, yeah, it's this picture of mine, I see. And
Okay.
many innocent people.
Can you recall the feeling?
Well, in a way it is similar, but on the other hand, it's not the same, because the talking itself, it's pretty much still the same. It's just the interaction is not the same, because usually people, used to raise their hands, shout their questions, throw things. Now they can do only, some little typing in a chat message, and that's it. So it is not that bad, but it's not as cool as it used to be.
Yeah, let me tell you a little secret. So at the beginning of the day, we had like a hacking session.
Yeah.
One of our speakers. And in the meantime, we managed to hack a little bit, the cameras. So if you look at the camera, you can see people.
Yeah. I'm not a showman. I'm not a TV person. So sorry, I'm not a celebrity. I basically do what you guys are doing every day. I sit and look at the source code. So this is what I do.
And
not at the camera.
Looks back, right? And the source code looks
back. And sometimes it's not only looking back. Sometimes it just punches you, right in your face. Yeah.
Yeah, so true. It's so true. Okay, now just between you and me and off the record, what are
right. Excuse me?
Just between you and me and off the record, what are Java records?
Java records are cool new stuff, which is still not standard feature, but it's going to be, so it seems. And it may basically, it's not an intended purpose of them, but they may, get us free from all these balls and chains called getters, setters, equals, hash code, and so on. So basically, they are about data, not about typing furiously. So I think especially the Mac users should be happy, because theoretically their keyboards should last longer.
Okay. So, Peter, where are you based in?
You should see when you turn around, because I find it a little bit surprising that you have actually a Polish flag behind your back. Yeah, the banner, look, it has white on top and red on the bottom, so it looks like a Polish flag.
What a nice coincidence. We had no clue about that. It was not intended, but well, it's a nice coincidence, right?
Yeah, Jakub didn't tell you that. He's located in the northern Poland, right at the coast, and I live next to Wrocław, or auf Deutsch Breslau. So it's or it used to be the capital of Silesia, at least the Polish part.
Okay. With Jakub, we had another coincidence. So he likes bricks,
Yeah, exactly. Yeah.
Twitter account. And the other coincidence is that right now I'm watching a TV series, which is a Polish one. It's Science.
Yeah, I didn't do that, so I'm sorry. I can't discuss whether it's good or not. I've heard there is such series, and that's all I know about it. Sorry.
I know. I want to say that the Polish TV series are really good.
Thanks for saying that. I wasn't aware of it. I just watch, different series sometimes. It's difficult because, they are like swamp. Once you start watching them, then you wake up that it's actually 5 a.m. You have to go to work at 7 a.m. Usually, and the night is gone. So they are kind of risky.
So I feel you, because I did that last night,
I see. There you go. There you go.
The other TV series that I used to watch when I was a child, I'm born in the 78th, by the way, and there was a TV series which was created in 79, the one with Arabella and Rumburak. So ask any Romanian of my age and they will know it. It's like the movies of our childhood,
Yeah, so we didn't had Romanian cartoons at the time because I was born during the communism era as well. Yeah, I'm that old. Maybe a little bit younger. Still, I remember, from my childhood that actually we had at the time, because we had, I mean, kids find that quite surprising these days, but we had like one or two channels of public TV, and there was any other TV. So you youngsters, imagine you just have two programs, two channels in your TV, and there is just cartoons for like 20 or 25 minutes a day.
Right.
So in Poland, it used to be played at 7 p.m., but then the TV from Czechoslovakia emitted their own cartoons at 7:30. And we were living close enough to the border. So actually I was, having cartoons for a whole hour, half of in Polish, half in Czech or Slovakian. So different times.
Yeah, exactly. So I was doing the same with the, with our neighbor countries. So
Yeah, exactly.
no pagadi. That one
Yeah,
was
No pagadi. Yeah, Volki zajc, da.
okay. Good. So, Piotr, let's then uh, get straight back to the session on Java Record. So I'll just phase off, and then I'll
Okay.
give you the floor. Feel free to share the screen.
All right, let me do that then. Let me share the desktop. So this should be this one, and let me bring the slides for you. So these are the slides.
All good.
So are we ready to go?
Yes.
Okay, that's great. So welcome to this session, Java Records from the Intrigued. I think since you've stayed so long in the night, I mean, we should all start singing soon. Hello, darkness, my old friend. It's 5 p.m. and it's getting so dark. Anyway, so shortly about me, I'm self-employed. I mean, this is my usual workplace, okay? So this is where I work from, and I used to work like from here for, well, maybe not ages, but for years, certainly. So the lockdown meant to me like no shops, no gardens, no kindergartens, no school, but actually it didn't mean any changes in my whereabouts when it comes to working place. So this is where I work. I also put some blog posts from time to time on my personal blog post blog page, Software Garden. And I also work sometimes as a trainer for a few companies, one of them being Cementis. And when it comes to Java, well, that's a bit problematic. Even when I go on holiday, all these good times when we're able to go abroad for a holiday, even at that time when I went to Spain, Java was still behind my back. So Java is, I'm with Java since 1.3, so I've seen quite a few versions so far. And also Java is also behind my back, as you can see, when I'm on holiday. Okay, just a short disclaimer or safe harbor statement, caveat auditores. Everyone can be wrong, I can be wrong. Verify on your own and trust, and check stuff on your own. Okay, so records, let's go to the records. So there are preview features. They got introduced in Java 14 as JEP 3.5.9, and they also got continued as a second preview in Java 15 as JEP 3.8.4. I suggest you should click the links and read the JEPs. They are very nice specification. They describe what the records are about and so on. However, I'm going to show you some demos today. So one thing you need to remember when you like to play with records in Java 14 or Java 15 is that they are still at this stage of preview feature, meaning they can change in the future, or they can see some enhancements or tweaks or so forth. So they are not like curved in stone so far. And I don't have time to discuss today how, what does it mean to have a preview feature and so on and so on. So these are just 2 pointers to slides and video I made. I'm just going to show you how to do that in your IDE. So basically when you have your project, by the way, the code is also online, so don't worry. You can fetch it or clone it later. So when you select your modules or your project settings, you have to switch here in the project language level to preview features. That's crucial. Without it, I mean, it won't work. I mean, they should work in Java 16, but so far we've seen them as second preview in Java 15. That's why please remember about these preview features. And also, especially if you're using like older versions with Gradle and stuff, I mean, things sometimes get a little bit twisted. Please remember, you also, when you see like strange errors, like record is not recognized as a type indicator or whatever, please also make sure that you see this preview selected for all these modules, or especially this record module, because this is a module that I keep records in. All right, so records, they are actually a new kind of type declaration. So we have, for example, classes in Java as a type. We also have enums. Now we have records, and record is a restricted form of a class. I like to think and explain records as if they are, you know, like a cousins or not so distant relatives of enums. Like enum is a class, and you can have, you know, defined it, add new methods and so on. It's just you can't do everything in a record that you can do in a regular class, because enum has a different purpose. And so to say, it's a bit similar with records. So of course, don't go too far with this metaphor. It's just, you know, start thinking of them as a kind of, let's say, enhanced records or something, or restricted form of classes. They always implement Java lang record. I mean, there's a new class since Java 14, and this is how we define a record. So instead of saying class, of course, you can have like public and stuff here in the front. You can say record, and then you say the name, and then you say or declare also called components. We'll get to that. And of course, this is a body, because we don't have in this very case any methods. So this is how you do a record. And what records have? They have a name. That's really important. They have a name, and therefore they also have a type. They have record components, but they're not required to have any. I mean, you can possibly leave all the components, because why not? I mean, maybe some weird cases that will be needed. All these components become private final fields, my friends, and they also have generated accessors. Please remember, it says accessors, not getters. They are not the same. They also have generated constructors, like compact and canonical ones, and they also have generated equals, hashcode, and toString methods. So what they can is that they can define, or you can define in records, constructors, or redefine them, compact, canonical, and also custom ones if you're really that fancy. You can have all implementations of the generated methods as long as they match the signature. So you can override equals and hash codes, and sometimes even have to, because of the data you keep in the record. And you can also have extra methods. You can have static fields and static methods, and you can implement interfaces, because why not? What you, however, can't do in a record is that records cannot extend classes or be extended. They extend Java-like record, and that's it. But that's, you know, you can't even make that inheritance explicit. It's just extends is prohibited in records, whatever you try to extend or whatever you're trying to extend from a record itself. They can't have setters. I mean, like the setters we know, we could theoretically mimic that with mutable fields. I'll show you that. And they can't have any extra instance fields. I mean, if you'd like to have a field in a record, you have to declare it as a record component. And also about records, I remember, you know, this buzz before Java 13 came out, like on Twitter, like March this year or late February, and everybody was, yeah, records. So we're gonna have records. And so the other guys were asking, so what actually are these records? And they said, they are just like JavaBeans, only not mutable. And the answer was, no, they're not JavaBeans. I mean, they're immutable, that's true, but they're not JavaBeans. I mean, records are records. They're just plain old Java objects with accessors. And the best thing I'd like you to think about them is like named tuples. You know, when you extract data from a SQL database, we usually see them as rows, but, you know, from theory and so on, they're actually tuples. In Scala, you also have tuples on the unknown. And records are actually named tuples. So a tuple which has its own name and its own type, so we can mix them by accident. And I think that's really cool. And it's done this like this because of this Java's policy to make everything obvious and named and so on. So records can also be nested, and that's really, really cool because you can nest them, and when they are nested, they behave just like static classes. But what's even cooler, you can nest them inside methods when you like to use them in collectors or something like this. Yeah, that's very handy for string terminal operations and reflection of the records. So there are two new methods in a class. One is called isRecord, and then basically just returns you a boolean saying whether this class is a record or not, pretty much like an enum. We also have this method isEnum, and we have another method called getRecordComponents, and it returns an array of the components. I mean, not the values of the components, but it's just for reflection and so on. So basically all these components, like their classes or types and whatever. But there's one thing I'd like you to remember when it comes to records. So I saw this brilliant tweet of Sergei Yegorov. He posted it last autumn, and after that he became Java champion. So I think he really deserved that, at least for this tweet. So follow with me this video. See, so this is not how you should use reflection. Reflection is not meant to overcome some stupid limitations of your library. So in the first place, try to use records as they should be used. And you see, Sergey got like almost 700 likes. I think he'd like to get some more new likes on this tweet. So we have the link here. You can find this tweet and give him a like. I think he really deserves this. Okay, so serialization of the records. Records are objects which can be serialized, but what's different from actually deserializing these records from regular objects is that the reconstruction is not done using any fancy schmancy methods. It's just done using the constructor. So the serialization framework under the hood is going to call a constructor to reconstruct or deserialize the record. And this is a bit problematic because, of this beans everywhere, getters and setters everywhere. We became so hooked to this concept of JavaBeans that various libraries and frameworks have issues with handling records, basically. So I'm going to show you that as well, I hope. And if you'd like to know more about records, I mean, like beyond this this presentation, I'd like to invite you to my page, when I also like have written a few entries on records. Okay, but this was just slides, this was just propaganda. Okay, let's go back to real code, because this is what we trust in. We trust in code. So I don't know about you, but I studied at a technical university, and we had let's say more sophisticated mathematics there, and we also had a thing called complex numbers. So basically, it's just like this number can be represented as a point, but it's I mean, if you'd like to have a square root of -1, you get a complex number I. So this is where they're useful. That's why they have the real part and they have the imaginary part. And as you can see, I've just added here record. So it's not class, it's record. I mean, this is a class also, but this is a special kind of declaration. So it's a record. So you can add some like public or private or whatever. And then there's a record and there's the name. And here we go with the components. So in this very case, we have just two. And how do we use them? This is how we instantiate them. So as you can see, I can just create a new instance of one complex and another instance of the complex, and I can do stuff with them. And if I'd like to get like the components or the values of the components, this is how I can do that. See, like Z1, and then I have this real, or I can go for, let me semicolon that, or I can just have Z1 dot imaginary. So see, I don't have this like get in here or whatever, or is or was or has been or blah, blah, blah. It's that simple. I mean, the name of this dictates the name of this accessor. It's really simple, no magic, no regexes, actions, nothing like that. So anyway, I just have two numbers and two complex numbers, and these numbers, you know, just like every other number or like ordinary numbers we know, they can be added, they can be subtracted, or they can be multiplied. So I have some operations which I, you know, coupled, or they just belong to this data. So this is, you know, a perfect example of object-oriented programming. So I have this complex, and then I have that complex, and as in return, I have to summarize the real parts, and I have to summarize the imaginary parts to have a, you know, just another complex number, which is a result of the other two. And as you can see, I just can do that. I can multiply them or whatever. Well, why not run it? Let's run it, okay? Because I can be talking when, and you can see it running. Yeah, so as you can see, it says hello records, and this is the how I, you know, multiply these numbers, and this is how it looks when I just, you know, printed out this number. And I have also told you that we can not only add new methods like this, but we can also override methods like this. So what happens if we rely on the default toString method? This is what happens. I mean, this is the standard output of the toString method for a complex or for any other records. So this is the short name of the class, and then we have square brackets in here, and then we have the names of the accessors and the value, another accessor. They just follow the order from the declaration and so on and so on. But you know, at the university, we didn't used to write them like this. We used to write them like this. So basically, there was just the I as a suffix of the imaginary part, and we used to write them like this. So that's why I decided to override the toString method, or maybe you'd like to override the toString method because of the GDPR or anything like this. Okay, so this was just to saying hello to the records. Let's go to some basics. So what are the valid examples of the records? All right, so this is a code that runs. Let me show you it runs. Yeah, so I'm not cheating. Everything is running, as you can see. And let's just go through this code. So as you can see, I can declare a record which has absolutely no fields or no components. I can just declare a record with one component. I can have more components, and I can have methods. And this is actually a poor example. I mean, if I had to review this code, it wouldn't pass. It's just an example. Please remember that, because in the record, I should have methods, I think, which only like operate on the data stored in this record or are somehow related to this data. And what this method is doing is just, you know, printing out something that it received as an argument. Nevertheless, I can add such a method. Technically, it's legal, it's possible. I can also have static fields and static methods, because why not? It's still possible. And what I can have mutable fields. I mean, as I have told you, all these components become public final fields. However, they can be mutable themselves, like kind of inside. So this is what happens in this very case. I have this counter in deep mutable field record. And when I call the bump method, the counter gets incremented. So as you can see, things are mutating inside this record. However, I am not able to change the instance of this record and by assigning a new atomic integer in here. So once I create this object, this of course is a public final and has to stay. As I have shown you, we can also have custom toString method because maybe you find the default noisy or GDPR or whatever, and you like to overwrite it, why not? And you can also have custom equals and hashcode methods. And please remember that they call, and not just in records, but pretty much in every Java class, kind of like a Siamese twins. So they shouldn't be separated. Each of them should obey their contract, and also they should work nicely with each other. And if you have method, or sorry, a record which doesn't only have immutable fields, but some of these fields are mutable, then please remember that you have to override the equals and hash code, else you're going to see bugs. So as you can see, it's possible to do that. We also can have something like, I like to name it a custom or customized accessor. So see, I have this field, and I need to, I can re-implement this method called just secret without any get, is, was, has been, or whatever. What I can do some extra stuff here. However, this method should behave, so it needs to have exactly the same signature and return the stuff it's supposed to return, I think. So please don't implement, like, I don't know, returning random numbers this way or anything like this. Please behave. And also we can override so-called canonical constructors, because, you know, sometimes we need to assert the data before it's constructed that it's correct. So in this very case, I like to make sure that this field is not equal to this field, and this field is not equal to D, basically. So this is what I do. I do that here, and then I have some, you know, just for a bit more checking, like custom canonical constructor code you see here. I'd like to show it. However, I told you at the beginning that the records have like a, you know, side effect that we are less and less verbose. So just to add these two assertions, I had to repeat this list in this constructor, and I had to repeat these bloody 4 lines with the assignment. I mean, it's repeating myself, right? So why not have something like this, which is called compact constructor? As you can see, I don't need to re-implement this list here again, and I don't need to re-implement this assignment. Is done like thing under the hood. What I care about is the actual stuff I'd like to do in this constructor. So these assertions, so I put them here. As you can see, this constructor doesn't have any list of arguments. In fact, it's not even empty. See, it doesn't work, just no list of arguments. And let's say we have a custom, like really fancy record, and in this record we'd like to store the length and the hash of given string. For example, we'd like to keep that as a value for a map where keys are strings or something like this, and we don't trust the internal hashing of string or whatever. It's just a dummy example. And nevertheless, as you can see, I can have a custom constructor totally. I mean, I have fields which are int, but the only argument is not an int, it's just string. So what I'm calling is just this canonical constructor, and just filling it with the length of the string and the hash code of the string. So I'm also, you know, able to do and to create totally custom constructors. And what also we can do in records is that records can implement pretty much any interface. So as you can see, I'd like to be able to compare these two records by comparing A and then comparing B, and see when I compare them, this one and this one, we get -1. So if you'd like to implement a method like comparable, you see, then in your class, you need to have this overridden compared to method, so it's still possibly legal. So it was illegal. Let's see some limitations. Again, this code runs, and it runs only because I have this piece of code commented out. So as you can see, I mean, this would be a pretty dumb idea to extend a class like Java util date. Nevertheless, it's impossible because does it show a message? Yeah, no extends close allowed for records. So records cannot extend anything, even see, they can't even extend Java long record. See, they can't extend anything, just anything. Also, they cannot be extended. I have this cannot extend, and I cannot extend this record like add another field or something like this. It doesn't work. Okay, so I cannot have any extra fields like super duper private fields, like really, you know, not visible in this constructors I show you in a minute. Sorry, a minute ago. It's impossible. And also, you can't have certers, like this field becomes, or this component becomes public, private final field, and the final means that I cannot reassign this value because final variable field, as you can see. So we don't have any setters. Okay, so let's go to this nesting example. As you can see in this example, we have just an inside class, and I have enclosing class, and this enclosing class keeps an inside class. and I'm able to reference the field from this enclosing class because this class isn't nested. But once I make it static, as you can see, it becomes nested, and what does the error say? Cannot be referenced from a static context. So from a static context or from a static subclasses, I cannot reference fields of the enclosing classes. So as you can see, this is exactly the same error we're going to see from the records, which means that records are behaving, once nested, of course, like nested or static inner classes. So please remember that. But what you can do with records, I have this very nice example. I use that for describing the new collector called Team Collector from Java 12. Nevertheless, to do that, before, let me just comment this out. To make this code run, I had to create very minimal implementation of the bean approach. So I had these two fields, count and sum, and I had a constructor, taking both, assigning these fields, and because they are public, I don't need any getter, and because they are final, I don't need any setter, and I had to overwrite to string if I didn't want to see some rubbish from the memory to make it run. And what I'm just doing, as you can see, I'm using that in a team collector, or I'm using that in a reduce method. As you can see, this count and sum. And once we run it, yeah, it just summarizes how many items I have and total value of the items in the stream. However, as you can see, I needed that many lines of code. I mean, these lines of code. And please remember, we don't have any getters, setters, equals, hash code, nothing like this. Just constructor, fields, and to string. But if we'd like to do something like this using record, this is all I need. Just this single line. Record, count and sum, and then I have the count and the sum and empty body, and that's it. And once we run it, see, this is what I get. I get exactly the same result, and this is what I told you. We can declare a record inside a method. See, I'm inside the main method, and I'm using this record only for the purposes of this computation inside the main method. And of course, it's not only about main methods, it's pretty much about any method. It's just how they work as a named tuple. So you need a named tuple, like a temporary accumulator, to return 2 things, 3 things, I don't know, 17 things, for example. So we can declare that many components, and then you can use them instead of returning these clumsy arrays, because I don't think this is a nice way of returning stuff. And you don't have to declare classes like this. You can just use pretty and nice and really minimalistic records like this. Okay, so how much time do we have? Okay, we still have a quarter. So maybe let's go to this JSONification, I call it. Because, or maybe let's start with the serialization. So let's start with serializations. I have 2 classes. So one is the bean check. I have I have a bean which implements serializable. I'm not sure if I like to implement serializable. Nevertheless, let's say it's a kind of a legacy code or something like this, or you're perfectly happy and you're perfectly aware what this really means. And many times it means nothing but trouble. Anyway, we have just one field, and I have a constructor, and I have a actually, see, it's not a getter, it's kind of an accessor. So this is what I have, and I have a record which just mimics the very same thing, only with fewer lines. I'll show you in a minute what these are commented out. So I have just, again, one string field, and that's it. That's pretty much it. So as you can see, and this is what I like to show you in this demo. I mean, you can, if you really fancy, you can close this code and you can examine the bytes. I mean, this is the output of stored bytes for the record, for the bean, and you can find out that they start to differ from, I forgot, it was like, where was that? Anyway, there is one position when they start to look different. I mean, the format of serialization of objects and records is a little bit different. Nevertheless, we can serialize them, and then we can deserialize them. And as you can see, I'm writing here the serializing object. So when I'm the serializing object, and it's just what is it? And it's the record, then I see this line. We are creating record for ABC. And this is the context between like deserializing and deserialized, right? So this is like this, and this thing we are creating record is printed here by this invocation of read object. And we don't see anything like this for the bean. So why is that? It's because this thing we are creating record for is called by, or is written by this constructor. See, it's a constructor. So this is what I told you. The records are deserialized by the constructor. So this is how they behave a little bit different. But I am pretty much certain a lot of us, should I say, work on these REST APIs, and we JSON stuff, and we read from JSON, and we create JSON and so on. I mean, we exchange XML for a JSON and YAML, and we're still doomed. Anyway, let's be a little bit optimistic. So I have this mapper from Jackson, and I have these two classes again. So I have this bean and the record, and what I'd like to do is I'd like to serialize them, but this time not to Java's format, I mean the binary one, but to JSON. So this is what I do. See, I just write them as value strings. So this is normally what our frameworks would do for us, more or less. And when I try to run this code, whoops, it doesn't work. So let's see why. It doesn't work because no serializer found for class, blah, 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 disable serialization feature fail or empty beans. So I have this bean, yet in this line, it's throwing an error, an exception, because it looks as if this bean was empty, but come on, I have this field here right now. It's just this bean doesn't follow the bean convention. So to fix that, I can do one thing. I can, as you can see, have this, or uncomment this getter. And then it's working because I was able to serialize the bean. Now it's failing on the record. So this, as you can see, now it's failing on the record. So this is one way we can fix that. Or the other way we can fix that is we can annotate either this field or this accessor-like method with JSON property. So this way we're telling Jackson, hey, this is my property, please serialize it. So once we run it, things are still working pretty much the same way. So the bean got serialized, but we weren't able to serialize the record. So what can we do for serializing the record? Again, we can do the same thing. So we can put the annotation here, you know, just in front of this, just in front of this field, or maybe when I add the, and make it work like this, it becomes nice, see, and here. Yeah, so this is the format we all know, I believe. So now I can say that this record has a single JSON property with just one field. So when we run it, you see now it was nicely serialized. So both the bean, both the record got serialized. However, this is how things are running with Jackson 2.11.2. But if we switch to something that's going to be version 2.12, and now let me find this little button here. So I'm reloading the Maven configuration. Things are going to be a little bit different because the Jackson from version 2.12 is going to recognize records. So this is what I meant when I was saying that the libraries and frameworks need to adapt. So as you can see now, let's run it. Yeah, it's running. Now, as you can see, this thing is working even without this pesky annotation. So Jackson is recognizing, it's calling this isRecord method, using reflection for us, so we don't have to hammer the spoon, and it makes this nice format for us. However, this is just halfway through, right? Now we need to deserialize, or we need to parse the the JSON format. So once we do that, and what happens? See again, oh my, it doesn't work. I mean, it can't deserialize this bean. So why is that? It's just because this bean, ladies and gentlemen, doesn't have a thing called deserializer, if I'm not mistaken. Yeah, it cannot deserialize, no delegate or no property-based creator. So we need a thing like property-based creator. So to have it, we can just put constructor properties above the constructor, and using this, our beloved Jackson will know that it should call this constructor to construct object of serialization bean check from the string. But as you can see, I didn't have to add it for the record. I mean, I have it here just to be ready in case I'm still forced to use this old Jackson, because usually you don't run the snapshot versions of in production. But as you can see, we can now compare the beauty of this solution. So I have just record, okay, it's only for storing one field, but you know, if I started to add more fields, it would be even it would be looking even better, or I mean in favor of the records instead of the beans. So I have just this nice declaration, I have this redundant call to show it how the serialization works, and this is it, just to store data in JSON. I don't need this code, I can get rid of this code, and let's get rid of this code here, and see now they are comparable solutions. Provided, of course, because I don't have this getter, because maybe I'd like to have this getter. So if I have this getter, then I don't need this, and I don't need this this property to make this con run. I mean, this annotation. See, the code is still working the same, only, haha, I don't have this toString method. Of course, I don't have this method because it's not generated. I will have to add it. So see, if you need data types, like value objects, data transfer objects, whatever you call it, just something to represent the data you fetch from the database, and stuff like that. Or when you're creating, you know, this input to be then turned into JSON and so on, having these beans may be really verbose and tedious and really error prone, because then you need to remember, did I regenerate this equals method and this hashcode method or not? Right? And for the record, you don't have to do this. It's just it. It's just it. So it's that beautiful, I would say. Yeah, so shortly about the reflection. It should be this. Yeah, let's run this code. I mean, normally we shouldn't be interested in this example, but it's here just for sake of completeness, in case you're that intrigued. So as you can see, we're just grabbing the class of enum object, and we're calling if it's enum, and by you know, similar approach, we're calling the isRecord of this class. So yeah, one object is record, sorry, enum, the other is a record, and then you can find the examples of these get records components. So we get an array of a new type called record component, and then I can stream for these components and investigate the properties. So as you can see, I can show the name of the record component, the type of the record component, the canonical, the canonical name of the type. I can even find the declared record. It's all written here. You see, it's written, it's the component. Let's maybe start with the, yeah, it's here, of course, at the beginning. So these are just these two lines, and the difference, because I'd like to, you know, put an emphasis on the fact that the records aren't beans. It's just when we describe the bean properties like this, we call the bean info get property descriptors of this, like proper bean, which is bean with setters like this. See, it's a bean with setters. Then what we have, we have these properties from bean's point of view. So we have a property And this is the class property. Of course, every object in Java has the class property. Then we have this ID property, and it only has this read method. And then we have this string field property, and it has this read method and also write method because it has this setter. So in case you'd like to, you know, handle this beans by reflection using bean descriptor, you can find out, you know, this getter, and this setter. And things look a little bit different for when we try to describe bean properties of the record object. The record object we created here, like the reflection check. See, it's this record. It has just two fields, pretty much like this has two fields. And here we don't have any other bean properties, but the class. That's why when Jackson by default in 2.11 sees a record, it thinks it's an empty bin, because this version of this very library is not aware that records are something different. And now, please don't get me wrong. I'm not trying to say that Jackson is not behaving properly or something like this. It's like nobody expected Spanish acquisition and nobody expected records. However, this is a perfect example how preview features are working. You see, the records were added as a preview feature for Java 14, and now you know, the version or the release candidate is there. So this is not even a standard feature yet. Jackson is ready to handle it properly, and this is the very purpose of the preview feature, to give everyone a year to get ready for a standard feature, to give it a try, to provide some feedback, and so on and so on. So it might be, I mean, I was using Jackson because I'm sure a lot of us is using it, but you need to be aware that your framework for serialization, for data handling, for anything might not be aware of the mechanics of records. So, you know, test it, provide some feedback, provide some handling, implementation, and so on. So back to the pesky slides. Please remember, my friends, not only for me, not only for this camp, code camp, but for every event you take part in, and for every speaker, for every session, please always provide your feedback, because we value your feedback. I mean, but the speakers, both the organizers. So when they send you this link for a poll, please spend 3 minutes or something like this and fill this poll, so we get your feedback and we know what to improve in our future talks. And in the last case, you can even send me a paper form. Why not? I still accept it. So that would be it. You have two links here: link to this presentation, link to the code, and yeah, and this is again the link to the code. Sorry, the slides in case you'd like to scan it, because everything is online for you. And I think we might have a few minutes for questions if there are any.
Yes, we have time, and yes, we have questions. First of all, for the presentation, very engaging, I would say, and very energetic. Then I very much appreciated the fact that you mentioned about the feedback. Yes, we rely on your feedback and we get better based on your feedback. Now to the questions. So records are promising, right? They are like a new toy or new tool, or but in the wider landscape, with object-oriented programming, with relational programming, with aspect-oriented, and so on and so forth. Where do they fit? Or
I would say they fit perfectly pretty much everywhere where containers for immutable data are needed. And this is just my personal reading, so please don't take it as an official statement of anyone. Like, I don't work for Oracle, I'm not one of the Java architects, but from my point of view, it's one of these tiny, or maybe not even tiny, but one of these changes that's pushing Java towards declarative and functional style of programming. And it's not that the imperative style is going to abandon, nothing like that. I mean, everything is like beans are going to stay and so on and so on. It's just now, you know, we were given like these streams and so forth in Java 8. Now we are going to be given it probably in Java 16 records. And what's more important is that we also have other features in Java. I didn't discuss them today, like switch expressions, and we also have smart casting, aka pattern matching. And records come from one of these umbrella projects, and this very project they come from is called Project Amber. And Project Amber is about all this. I mean, they look very tiny and small, but effectively they make us much more productive. So most probably in the future, we're going to see pattern matching with data deconstruction, with extracting data from the records, possibly from other types. So this is just the first step. In the future, we're going to see Java to adopt and to benefit from records even more.
Right. The other thoughts that I'm seeing in the chat coming from the audience were related to immutable usually sits very well on the same table with parallel computing.
Yes, exactly. So this is like when we're using strings, for example, or strings. I mean, this was like this Freud mistake, but it's actually what we do, right? So previously we had, for example, we still have this Java util_date, which is pesky, which is mutable, and so on, and it wasn't thread safe and stuff. However, from the day zero of Java, we had strings which are immutable, and now we have like data containers which are also immutable, and that's exactly it. I mean, if you have no moving parts, if you have no side effects, then parallel computing and stuff, it's really much easier. You don't have to give it so much attention as before. So I mean, once records become the standard feature, they will be my first choice for any kind of data components. So I would say, I would risk even this statement that if you're using value, I mean this value annotation from Project Lombok today, pretty much you're okay and you're safe to use records in the future.
Okay, thank you. The other thought was around the relational and object-oriented worlds. Are, among other things, a sort of a bridge, or could they be considered as such? Or
I think they basically don't care. I mean, records are nice and they can represent like, I don't know, like a view, entries, rows, or tuples, or whatever we call them, if we get them from a SQL database. It's just if you have this assumption that they can represent a row and you can change something and then persist the row, then they're not going to fit into this role. However, maybe it's not the way you should be working with your database in the first place. I mean, this was kind of this active record approach. So records are not going to work for active record. However, if you have CQRS, they are going to work with that, I think.
okay, there are some other questions around, I don't know, if you have at hand some use cases of records, recent.
I mean, I don't use them in production code because they are still not standard feature, and we are not allowed to use preview feature, and that's kind of understood. I mean, that's reasonable. However, I use tuples a lot in Scala code. So everywhere when I used Scala's tuples, I think records are perfect fit. And if you were using class like from Apache Commons, like this pair or triple, they're going also to work very nice in this area. So like this, common problem we have, like we don't have output parameters in Java, obviously, like in other languages. So we can return one thing and one thing only. I mean, one thing from a method, basically. So what did we used to do when we had to return two integers? Like I have shown you, like the total and the count, for example. So we had to create another bean or mimic that with an array or something like this. Now we can have a record, and records are great for that. They're great for nesting. They're great for stream processing, for all these collectors and so on. Basically, whenever you have this huge diagram somewhere in your company and it describes, this wall with the architecture, and you have these DTOs, which are data transfer objects, and you have this value object somewhere in there. So you can, I think, start thinking about replacing them from this bean convention into using records.
Excellent. Very, very insightful. And I thank you so much for being with us this evening. I hope
Thank you.
again at the next editions. We had quite a day.
Yeah, and in fact, I'm a little bit upset about this whole situation because this is the second Great Romanian Conference I had to do or not do in person because of the COVID. You know, so I already missed Vox Days. Now I missed you. I mean, I missed that in person, and I find this really frustrating. But let's hope for better times.
Thank you so much. We take it as a compliment, and yes, let's hope for better times. Let's have patience, and hopefully soon next year we'll get the chance to meet in Romania.